So in 12.1, we really concentrated on how to solve two-step equations when the coefficient of the variable is a fraction. But now we're going to put fractions in other locations, way more fractions. Here's the good news. You can get rid of them. And here's how. So, right, in our last lesson, we had a fraction for the coefficient of x. And now we're going to learn how to get rid of fractions in this lesson, but for these two problems, you wouldn't get rid of them. You would do these problems the way I taught you, right? It is the fastest way. So we subtracted 7 from both sides. We multiply both sides by the reciprocal of 1/3, 3. Here, x is 15. Here you subtract 9 from both sides. 3 minus 9 is -6. Multiply both sides by 7/2. And 2 makes that -3, and -21 equals x. But now we're going to have fractions all over the place. Right. Now, could you solve this by adding 3/5 to both sides? You absolutely could. But there turns out to be a nicer way to do it. It turns out, right, we've learned that if you do something to both sides of an equation, you have to do it to both entire sides, then the equation remains true. So what did I do to this equation with all these fifths in it? I multiplied both sides by 5. Why did I multiply both entire sides by 5? Because it lets me cancel all those 5 denominators. And so instead of solving this thing with all the fractions in it, I get to solve x minus 3 equals 5. Add 3 to both sides. Done. One of the best tricks in algebra. Whenever there are fractions, you can multiply by something to get rid of them, but you have to do that to both entire sides. If there's 9 things on the side, you have to multiply all 9 things. That's the downside of this trick, but it's a great trick. Okay, so let's start. So we're trying to get rid of this 4. What will cancel this 4, right? We subtract 3/4 from both sides. Yeah, but then you got to do 6 minus 3/4. You get 5 1/4, but you can't deal with 5 1/4 because you're going to have to make it a mix to do more things. You're going to have to make it an improper fraction because you can't multiply improper fractions. There's a lot of garbage involved in doing it straight. So the better way to go is to clear the fraction. So all you got to do is multiply by 4. Now, you're going to multiply everything on both sides. So even though there's not a 4 here, you still got to multiply that entire side by 4. That's the key to this trick. So those 4's cancel, we get 1x, which is x. Those 4's cancel, we now have 3. But you have to multiply the 6 by the 4 as well. That equation and the one we started with both have the same answer. Which one would you rather solve? I would go with this and say x is 21. It's called clearing your fractions. So, well, you got to multiply both entire sides by 7. So those cancel, you get x. Minus 7 times 3, 21. Those cancel, you get 5. Now you can solve that one. Add 21 to both sides. A lot of 21s. X equals 26. If you put 26 into this equation, that's what you'll get. 26 minus 3 is 5/7. How? Well, because 26/7 is 3. 3 times 7 is 21. 3 and 5/7. Yeah. So I just checked my work there by doing that. Okay? So the only number x could be is 26. Now, it's easy peasy when the same number is down there. For more complicated ones, you have to pick the least common multiple of the denominator. So what is the least common multiple? Right. It's the lowest number that's on both times tables. Remember how I taught you to do this. You go through the larger times tables, which is 6. Is 6 on the 3 times table? Yes. Now, you're going to multiply everything by 6 here. If you multiply by 3, say, there'll still be a 2 denominator there. So you need, it's never going to be, it's going to be the bigger number or larger. Okay. So if you have 3 and 6, it's going to be 6 or bigger. In this case, it is 6. You can multiply everything by 6, and once you do that, canceling should get rid of all fractions. So let's see that. 3 cancels with 6 becomes a 2. These 6 cancel. This 3 cancels with 6 becomes a 2. So this becomes 2 times 1x, which is 2x. This becomes minus 5 because both 6's are gone. Now this becomes 2 times 2, which is 4, right? It's 4 over 1, but the 3 is all the denominators are gone. And 2x minus 5 equals 4 has the same exact answer as the one we started with. We're going to add 5 to both sides. 2x equals 9. Divide by 2. The answer is x equals 9 halves. Yes, a lot of these are going to have fraction answers. Could you, since 8 halves is 4, you also could write 4.5. You could also write 4.5, but why would you? It's with fractions already in it. All three of those are correct, though. All right, so same thing. So I need, if I multiply by 2, I don't get rid of the 7. If I multiply by 7s, I don't get rid of 2. But what will get rid of both of them? Hopefully you realize it's 14, the least common multiple of 2 and 7, right? 7 doesn't do it, but 14 is on both times table. You need a number that is on both times tables. 6 is on both, and 14 here is on both. And you want the lowest one. Now you could use any multiple that's on both the 2 and 7 times. You could use 28. It'd just be more work. But any multiple will work, but you want to try to multiply by the least common multiple. So 2 goes into 14, 7. 7 cancels with 14 becomes 2. 7 comes 14 is 2. So we have 7 times 1x, 7x. Now we have 2 times 5 here, minus 10, right? There was a 5 here, there's only a 2 there now. And we have 2 times 2 over here, which equals 4. 7x minus 10 has the same answer, equals 4. Add 10 to both sides. 7x equals 14. Divide by 7. X equals 2. Yeah. So let's try this one. So what would clear 5 and 2? Hopefully you realize it's 10. 5 cancels the 10, becomes a 2. 2 cancels the 5, becomes a 5. 2 cancels the 10, becomes a 5. 2 times 1x, 2x. 5 times 1, 5. 5 times 7, I really should write that we're multiplying here. 5 times 7 is 35. So that's the one we're going to solve. We're going to subtract 5 from both sides. 2x is less than 30. Divide by 2. X is less than 15. Now, so we're going to clear 2 and 10. Now, you could use 20, but the truth is the least common multiple is 10. And remember, you got to multiply the 3 times the 10. So that becomes 5x. That's minus 1, and that becomes 30. The only mistake usually on tests and stuff is right there. You forget to multiply the entire side, even when they don't have a fraction. So 5x equals 31. I warned you that this was going to be a fraction, and it is. It's 31 fifths, right? 30 fifths is 6, so it's also 6 and 1/5. It is also 6 and 2/10. I don't know why you do that. All of those are correct. So what's going to get rid of 3, 2, and 6? Right? 2, 3, 6. Is 6 on both the 2 and 3 times table as well as the 6? Yes, it is. So you multiply everything by 6. 3 goes into 6 twice. That becomes 2x. 6 goes into 2 goes into 6 3 times. Minus 3. 6 and 6 cancel, and you get 5. And you get to solve this nice, easy two-step equation instead, and x equals 4. Now, you'll do more of this in algebra, but you're not just trying to get answers with this. You're going to be manipulating equations. So we want to see which one of these three has the same answer as that one. So how would we do that? None of them have fractions in them, so we better clear the fraction. What would clear both 5 and 10? It's 10. 5 and 10 cancel 10, it becomes a 2. 2 times 2 is 4x. So I'm thinking that maybe the B is wrong. We'll see. 10s cancel, minus 3. It's looking like A. Let's see, these 10s cancel. Yeah, the one that has the same answer is A. So a sunflower grows at a rate of 1 1/4 feet per week. When it was planted in the ground, it was 6 1/4 feet tall. If the sunflower is currently 12.5 feet tall, write and solve a two-step equation. So, right there is our rate, 1 1/4 feet per week. That's our unit rate. It's going to be our coefficient for W, but we're not allowed to use mixed numbers in equations. So we're going to write 5/4. Could you, now we're doing fractions, so we're going to do it with 5/4. Could you do it with 1.25? Yeah, you could, but it would be slower. So when it was planted in the ground, it was 6 1/4. There's our constant. So 6 1/4, 25/4. And if the sunflower is currently 12.5 feet tall, right, so 12.5 is our total, our current value. That's 25 halves. Right, so we're going to clear so that's the equation. We've written our equation. So now we're going to solve. So we're going to multiply everything by 4, right, because that'll clear everything. And the one we're going to solve is 5W plus 25 equals 2 times 25 equals 50. Subtract 25. Oh my goodness, look how much easier that got. 5W equals 25. Divide both sides by 5. And it's 5 weeks. This has been growing. We know that it's growing 1 1/4 feet per week. And we now know its current height and where it started. We can work backwards and figure out how many weeks it's been growing. So let's practice. So in the first one, we have to match it to one of these equations. So even if you wanted to, say, add 3/10 to both sides, and on this one, that wouldn't be so hard, 7/10 plus 3/10. You could do that, but the problem is you need to match this with an equation that has no fractions in it. So you're stuck clearing it no matter what. I think most people would want to do that anyway. And so we get 2 times 2x, 4x, so it doesn't look like this one, minus 3 equals 7. Yeah, it's A again. Hey, what's going to clear 3, 12, and 4? I believe it's 12. We're going to multiply everything by 12. 3 goes in 12, 4. We get 4x. 12 goes canceled, plus 1. 4 goes in 12. 3 times 3 equals 9. Subtract 1 from both sides. 4x equals 8. Divide by 4. X equals 2. So what will clear 7, 14, and 2? I believe it's 14. 7 cancels with a 14. This is 2x. The 14's cancel. You get minus 5. Greater than 2 cancels with 14 becomes 7. Add 5 to both sides. 2x is greater than 12. Divide both sides by 2. X is greater than 6. Good luck with homework.